So questions 1, you have two parallel metal plates are connected to a 120-volt battery as shown in figure 1. So you have figure 1, the figures 1, it looks like capacitor questions, but in fact it is not. You are given two parallel plates. In chapter 1, we have a subtopic that is related to two parallel plates, which is a uniform electric field. So when it comes to uniform electric field, you have only one equation in this subtopic, which is E equals to V over D. By looking at the questions, you should know which equations to be used already. So questions 1A1, calculate the electric field intensity. So electric field intensity also represents electric field strength. Okay, that is the name for E. The symbol capital letter E, it has three different names: electric field intensity, electric field strength, or just electric field. So this question, it asks you to calculate electric field intensity. So it means it asks you to calculate E between the plates. So how are we going to solve it? Obviously, this is the equations that you need to use. So questions 1, we have E equals to V over D. Okay, and then now you have to substitute the value. When you want to substitute the value, make sure they are all in SI unit. Okay, a few of you who got the wrong answer, who got it wrong because you didn't change the distance between two plates, which is 2 cm into meter. So V given is 120 volt. And then D, the distance between two plates, is 2 times 10 to the power of negative 2. So the final answer is 6 times 10 to the power of 3. Now, what is the unit? You are using V divided by distance. So it's V and negative 1. So these questions 1, if you got the substitutions correct, then you get 1 mark. And then if you got the final answer with unit, you score the second mark. Oops, sorry, it should be 1 mark. Okay, so 1 mark for the substitution, 1 mark for the final answer with correct unit. Okay, so that's why if you look at your paper, I mark it as G and then JU1. G stands for gantian. JU1 means you need to have jawapan and unit. Okay, kalau kamu tengok kamu punya paper, cara saya tanda, saya ada letak G atau JU. G bermaksud gantian, kena ada gantian baru ada marka. Kalau tak ada gantian, tak ada marka. JU1 means you need to have the unit. Okay, jawapan dengan unit. Mesti kedua-dua betul baru dapat 1 marka. So now let's look at questions number 2. Calculate the force on electron between the plates. Okay, calculate the force on electrons between the plate. So now let's say you have an electron right here. You don't know the position. Therefore, you cannot use F equals to KQQ over R to calculate it. When it comes to these questions, since you have electric field from the first question, from the questions 1, then questions 2, what are we going to do? Okay, we use F equals to QE. Okay, F equals to QE. Now, this is a questions that involve vector. So when you have a questions involve vector, okay, your F and your E, they are vector, then you ignore the negative signs of the charge. So F equals to, now Q, you're looking at electron. Electron, the value is given in the list of formula, list of constant, which is 1.60 times 10 to the power of negative 19. Electric field, you take it from questions 1. 6 times 10 to the power of 3. So the final answer is 9.60 times 10 to the power of negative 16. And the unit is Newton. So once again, if you got the substitutions correct, then you score 1 mark. And then if you got the final answer with unit correct, then you score another mark. Okay, then you score another mark. So that is how we mark it. Okay, that is how we mark it. So questions 1, 2 marks. Questions 2, 2 marks. Now, questions number 3. The loss in potential energy by an electron that move from plate B to plate A. If you look at this diagram, plate B obviously is a negative plate. Plate A is a positive plate. So if your electron is moving from B to A, means it's moving from a lower potential to a higher potential plate, which means your delta V should be a positive value. Okay, there's one of you who substitute V as negative 120, which is wrong. Delta V should be positive 120 because your electron is traveling from lower potential plate to a higher potential plate, from a negative towards a positive plate. Okay, now how to solve these questions? Quite a lot of you got the equations right, you got the value right, but then you got the sign wrong. Question C, you are looking at, question 3, sorry, you are looking at a scalar quantity questions. When it comes to a scalar quantity questions, then you need to take into consideration the sign of the charge. And you are looking at negative charge. So which means questions number 3, the loss in potential energy, delta U equals to Q naught delta V. Okay, your Q naught should be negative 1.60 times 10 to the power of negative 19. And a delta V is positive 120. Okay, positive 120. Therefore, the final answer, it should be a negative value, which is negative 1.92 times 10 to the power of negative 17 joule. So once again, if you got your substitutions correct, then you got 1 mark. Final answer with a correct unit, another mark. So altogether 6 mark for questions 1. Okay, altogether 6 mark for questions 1. 1A. So I give you 2 minutes to write it down. If you have any questions, you may ask. If no, we'll proceed to questions B. Now let's go back to questions number 2. Okay, there's one thing that I forgot to mention. Then how to determine the sign for this charge? Okay, for the Q. If you have a questions that involve F and E. Okay, so if the question asks you to determine the values of the charge, the Q, then how are you going to tell whether it is positive or a negative charge? Then you look at the directions of force and the electric field. Okay, if force and E, they are pointing towards same direction, then we assume it is positive charge. If force and E, they are pointing towards the opposite direction, then we take it as a negative charge. All right. So that one, I believe we mentioned it in the class before. Kalau lah dia minta Anda tentukan charge, okay, whether charge positive or charge negative that you are looking at. Then you look at the directions of the electric field and also the force acting on the charged particle. Okay, so for these questions, we cannot determine it because we don't know the magnitude of the force. We don't know the direction of the force, right? Okay, now, before we proceed to questions B, questions A1, electric field. There are quite a lot of you who determines questions 1 by using E equals to KQ over R. Okay, this is wrong. Okay, this is wrong. This electric field, we use it for point charge. Okay, we use it for point charge, the electric field at the point. You are having the wrong concept right here. How are you going to calculate it? Since you don't have the values of the Q. Okay, this Q represent point charge, but where is your point charge in the diagram? You don't have the point charge, then how are you going to answer these questions, right? So therefore, you cannot use E equals to KQ over R to solve your questions 1. Even if you got the right answer, it is just coincidentally you got the right answer. So you have the wrong concept. Wrong concept with right answer, it is considered as wrong. Right? So walaupun final answer kamu tetap 6.000, kamu dapat unit yang betul, nilai yang betul, tetapi dari awal konsep dah salah, maka satu soalan dia akan dianggap salah. Itu cara pemarkahan dalam exam Anda. Okay? So walaupun kebetulan Anda dapat nilai betul, tetapi konsep salah, jadi markah adalah kosong. So now let's look at questions B. Questions B, you are given 2-point charge, Q1 and a Q2. So Q1 is a negative point charge, and then Q2 is also a negative point charge. They are separated at a distance of 10 cm as shown in the figure 2. So now you have figure 2, Q1, Q2, both of them, they are negative. Distance between them is 10 cm. You need to change it into SI unit. If M is the midpoint between these charges, now let's say this is your M. So the distance between M and Q1, Q2, they are 5 cm. Okay, 5 cm. So the question asks you to determine the electric potential at point M. Electric potential, what is electric potential? Electric potential is V. Okay, ramai kira electric field, ramai kira E. It means that you don't understand the meanings, the name of the variable. So questions B1, the question is asking for V. V is equals to KQ over R. Equation is given, tetapi masih ada salah tulis. You write V equals to KQ over R squared. Always refers to the list of formula. You are given the formula. You shouldn't make this kind of mistake in your answer. V is just equals to KQ over R. So how to calculate the total potential now? You look at this question. You have two charges. It means total potential, you need to add them up. Okay, you need to add them up. So if you just calculate one potential, then that means you are wrong. So V total, V at point M is equals to V from charge 1 plus V from charge 2, which is equals to KQ1 over R1 plus KQ2 over R2. Now, the crucial part is the substitution. You are looking at electric potential. It is a scalar quantity, which means you need to include the sign in your substitution, in your calculation. So 9 times 10 to the power of 9. Q1 is negative 2. Now micro is times 10 to the power of negative 6. Okay, bukan negative 9, bukan negative 10, but negative 6 over R1. R1 is 5 cm, so 5 times 10 to the power of negative 2. And then since you're going to calculate the total potential, then what are you going to do? Plus 9 times 10 to the power of 9. Q2 is also a negative charge. You need to include the negative sign. Negative 3 times 10 to the power of 6 over 5 times 10 to the power of negative 2. So the final answer, okay, final answer, quite a lot of you got it right, but because you didn't have the negative sign, therefore you got 0 mark in this question. So it should be negative 9.0 times 10 to the power of 5 volt. Okay, times 10 to the power of 5 volt. So that is the answer. So when it comes to these questions, okay, this is also a 2 marks questions where your substitution, especially the substitutions with the correct sign, okay, if you got both correct, then you got 1 mark. Okay, you got 2 negative sign there, you got 1 mark. Final answer with correct unit, 1 mark. Okay, final answer with correct unit, 1 mark. So that is the questions B1, right? Questions B1. And then questions 2. The magnitude of electric field strength at point M. How are you going to calculate electric field strength then? Electric field strength, once again, it refers to capital letter E, right? So meaning that you have to determine the free body diagram first before you solve it. So at point M, okay, what happens at point M? Now, Q1 is a negative charge. When you have a negative charge, the electric field is going to be pointing towards the negative charge, pointing towards the charge. So this would be your E1. Q2 is also a negative charge. So the electric field, okay, the electric field is also pointing towards the negative Q2. So E2 is going to the right-hand side, E1 is going to the left-hand side. Then the magnitude of the electric field. You want the magnitude of the electric field, you want the total electric field. So electric field at point M, because it is vector, you need to take into consideration the direction. E1 going to the left, so negative E1. E2 going to the right, plus E2. Okay, negative because it's going to the left, and then positive because it's going to the right. So it is equals to KQ1 over R square plus KQ2 over R square. Okay, negative KQ1 over R1 square, negative KQ1 over R1 square plus positive KQ2 over R2 square. Okay, positive KQ2 over R2 square. Now, when it comes to electric field, because you are looking at the vector quantity, therefore you ignore the negative sign in your substitution. So negative 9 times 10 to the power of negative 9. Now the charge you substitute as a positive value. 2 times 10 to the power of 6 over 5 times 10 to the power of negative 2. And then don't forget the square. Okay, don't forget the square. Right? And then plus 9 times 10 to the power of negative 9. Because once again, you are looking at a vector, you are looking at electric field. So you ignore the negative sign. 3 times 10 to the power of 6 over 5 times 10 to the power of negative 2. And then square it. So your final answer, the magnitude should be 3.60 times 10 to the power of 6. Okay, and then what is the unit? Now the unit, either you write it as Vm negative 1 or you can write it as Nc negative 1. Okay, both are accepted. Both are accepted. Both of them, they are the units belongs to electric field. Okay, they are both electric fields unit. So when it comes to this question, once again, the substitution is worth 1 mark. So the substitution, we are going to look at the sign. Okay, the sign for the electric field, the sign for the charge. So if you got these 3 correct, then you score 1 mark. And then final answer with correct unit, you score another 1 mark. 2 marks for this question. Okay, 2 marks for these questions. So now I give you 2 minutes to tidy up your answer before we proceed to questions 2. Questions 2. Okay, now let's look at questions 2. Questions 2a. A parallel plate air-filled capacitor, okay, a parallel plate air-filled capacitor whose capacitance C is 200 picofarad. Pico, the value is times 10 to the power of negative 12. Okay, darab 10 kuasa negative 12. That is pico. And now you have an air-filled capacitor, which means this C is actually your C node. Okay, C kosong. So ramai dapat salah because you thought this is C. Well, questions give you C, it's correct because now you're looking at capacitance. Just that in our equations, when it comes to substitution, this one we substitute as C node, okay, C with a subscript 0, because it is the capacitance belongs to air-filled capacitor. It's charged by a battery to a potential difference V equals to 12 volts between the plate. The charging battery is then disconnected and a porcelain slab is inserted between the plate. So calculate the capacitance of the capacitor after the slab is inserted. So now you want to calculate new C. You are given epsilon R. Okay, this one is your dielectric constant. Dielectric constant is a constant without unit. Okay, so if you look at this value, it is a value without unit, then straight away you know it is a dielectric constant. The one with a unit, that one is the permittivity of dielectric material. So don't get confused between these three epsilon. Okay, you have epsilon, epsilon naught, epsilon R. Epsilon is just epsilon R is just a ratio. Okay, this is just a ratio, which is your dielectric constant. Okay, this is just a ratio without unit. So if you are given a value without unit, then that is your epsilon R. It's just a ratio. And this 2 is your permittivity. It comes with unit. Okay, it comes with unit. So epsilon naught is a constant value. The value can be found in the list of constant. Epsilon usually will be given if the questions wants you to calculate it, okay, or wants you to use it, then it will be given. Otherwise, questions won't tell you anything about it. Okay, now let's look at questions 2a1. Capacitance of capacitor after the slab is inserted. Now, obviously, you want to calculate mu C. So 2a1. So C is equals to epsilon R C naught. This is the equations given in your list of selected formula. So this is the equation that we're going to use to solve questions 1. So epsilon R is 3.2. C naught is 250 times 10 to the power of negative 12. Now, I would suggest you guys to write it down. Quite a lot of you, because you don't know the value, you write it as 250p. In this question, it can be accepted because you can write the final answer as picofarad. But in all the other type of question, you need to know the value. Okay, without the value, actually it's incorrect. All right, actually it's incorrect. But this question, coincidentally, the final answer is also in picofarad. That's why if you write P, I still give you full marks. Tetapi kalau dalam exam dicadangkan Anda tulis nilai dia. Jangan tinggalkan dia dalam bentuk prefix. Okay, sebab kalau kamu ada pengiraan yang lebih daripada satu step, then you are going to get the wrong unit. Okay, you are going to get the wrong final answer. So 3.2 times 250 times 10 to the power of negative 12. So the answer is 8.0 times 10 to the power of negative 10. The unit is farad. Okay, the unit is farad. So this question, once again, substitution, it worth 1 mark. And then the final answer with correct unit, it worth 1 mark. Okay, final answer with correct unit, it worth another 1 mark. Questions 2, it asks you to calculate potential difference between the plate after the slab is inserted. So what are we going to do when it comes to this type of question? Let us list down the information first. You have initial, which is before, and then you have final, which is after. Before you insert the dielectric, C naught is equals to 250 times 10 to the power of negative 12 farad. After you insert the dielectric, C is equal to 8 times 10 to the power of negative 10 farad. Before you insert dielectric, V0 is 12. After you insert the dielectric, V is equal to an unknown value. Now, the crucial part is the question tells you battery is disconnected. When battery is disconnected, then you should know that Q is constant. So you have Q1 here, you have Q2 here, but then Q1 equals to Q2. Okay, Q1 equals to Q2. That is the things that you need to know. So Q1 equals to Q2. If you got this right, if you know this relationship, then you get 1 mark. Okay, you get 1 mark if you know the relationship. And then Q1, which is your initial, your Q0, Q1 is equals to C0, V0, and then equals to CV. Okay, equals to CV. So what are you going to do next? Oops, sorry. So what are you going to do next? You just plug in the value. Okay, you just substitute the value. So C0, you have 250 times 10 to the power of negative 12 times 12 equals to 8 times 10 to the power of negative 10, and then unknown V. So V is equals to 3.75 volt. Okay, 3.75 volt. So if you got the substitutions correct, you got another 1 mark. Final answer with correct unit, another 1 mark. This is a 3 marks question because it tests your concept. It wants to see whether you understand Q1 is equal to Q2 or not when battery is disconnected. Okay, this one is because battery is disconnected. So once again, I give you 2 minutes to write it down before we proceed to next question. Okay, so questions B. Now, questions B, almost, I think almost 99% of you got it wrong. Okay, because you don't understand the questions. So when a capacitor discharge, so obviously this is a discharging process. When a capacitor discharge through a resistor, it loses 40%. Loses 40% means that you have 60% remain in the capacitor. Okay, you have 60% remains in the capacitor. So it loses 40% of its charge in 10 seconds. So you're looking at the charge in a discharging process. Therefore, the equation, okay, the equations that should be used is Q equals to Q0 exponential negative T over RC. So a lot of you got the wrong equations, okay? You select the wrong equation. This is the equation for discharging process. Q equals to Q naught exponential, bukan elektron. This E is stand for exponent. Exponential negative T over RC. Okay, so determines the time constant of the capacitor resistor circuit. Now, if you want to determine the time constant, first you look at the equation for time constant. Time constant equation is tau equals to RC. Obviously, you don't have the values of resistance. You don't have the values of capacitance right now. Okay, so what are you going to do? Then you're going to use the equation for a discharging process. So questions B1, we use equations Q equals to Q naught exponential negative T over RC. These equations can then be written as Q equals to Q naught exponential negative T over tau, time constant. So now you have time constant in your equation. Okay, now you have the time constant in your equations. So what are we going to do is, we need to determine what is the value for Q. What is the meaning for this Q? Q means the charge remaining in the capacitor. So what are you going to do is, Q is actually equals to, okay, the Q here is actually equals to 0.6 Q naught, not 0.4. A lot of you use 0.4. 40% is the charge losses in the discharging process. Okay, you lost 40% of the charge in this process. So the remaining charge is 60%. Therefore, Q final is equals to 0.6 of the Q initial. Okay, 60% of the Q initial. This is the remaining charge. Okay, remaining charge. So if you substitute it into the equations, then you have 0.6 Q naught equals to Q naught exponential negative T over tau. Q naught and Q naught, you can cancel it out. That is how we remove the unwanted quantity in our equations. So rearrange the equations. Ln 0.6 equals to negative, times given is 10 seconds, 10 over tau. Okay, 10 over tau. So if you got it right, the tau should be equals to 19.58 seconds. Okay, 19.58 seconds. So if you got the substitutions correct, what does it mean by substitutions correct? You got the 0.6 Q naught, then you get 1 mark. Okay, you got 1 mark. And then final answer with correct unit, another 1 mark. Okay, final answer with correct unit, another 1 mark. So now let's look at questions 2. The percentage of energy that is still stored in the capacitor after 10 seconds. Now, after 10 seconds, the numbers of charge is changing. And then you want to see what is the relationship between U and Q. That is our main focus. Okay, because you want to see what is the changes in the energy. Then you try to ask yourself, within this 10 seconds, what happened? Now, within this 10 seconds, you lost 40% of the charge. So if charge changes, Q changes, U changes in this case, in our question. Let's see whether it's correct or not. Let's try to find an equation that can link U and Q together. Because now the responding variable, the changes variable in this question is U and Q. Benda yang ubah adalah Q dengan U. So apa yang kita nak buat? Kita cari equations yang ada U dengan Q. So when it comes to these questions, the equations that we are going to use is U equals to 1 over 2, okay, 1 over 2, Q square over C. Okay, 1 over 2, Q square over C. Now these equations, let us play with it a little bit. Let us rearrange it. So U is equals to, I'm going to put a bracket, 1 over 2C Q squared. Now, the reasons why I write it like this, that is because this whole thing is actually equals to a constant value. Okay, it is equals to a constant value. Meaning that if you have this equation, then the things that we can say is U is directly proportional to Q2. Okay, U is directly proportional to Q2. So if you want to find out what is the final value, okay, you have initial U, okay, you have U1, you have Q1, and then you want to find out what is the remaining charge, or the remaining energy, remaining energy, then which means our U2 is an unknown. Then how about Q2? Do we have Q2? Yes, we do. Okay, Q2 is the final Q. Final Q, just now we say it is equal to 0.6 Q naught. So yes, we do have the value. So if you have U1, Q1, and Q2, and then you want to determine the values of U2, what you can do? Well, let's see. U1 is directly proportional to Q1 square, and now we know that U2 is also directly proportional to Q2 square. Okay, that is what we do know. So the constant variable right here, you can just leave it. When you have these two relationships, then you can just divide it, okay, divide them. So U1 over U2 is equals to Q1 squared over Q2 squared. Okay, so we solve these questions by using relationship, right? By using relationship. Now, of course, you can use the equations U equals to 1 over 2 Q2 over C to calculate everything first. Boleh juga, tak ada masalah. If you want to calculate the values of capacitance, then you apply into the second equations, also can. Nothing's wrong. Okay, but this is the shortcut. This shortcut can be used in every single chapter. Okay, this shortcut can be used in every single chapter. So now you have 4 variables, 3 of them, they are known value, only 1 unknown. So you have U1 over U2 equals to Q1 squared over Q2 squared. So from here, okay, from here, we know that, okay, we know that now our U1 is equals to, wait, yeah, let me see, what is the value for U1? Okay, U1, we use them as a 1, okay, it's a full value. Okay, it's a full value, it's a 100%. So let me flip it over, okay, U2 over U1. It is equals to Q2 squared over Q1 squared. Because now I want to see the percents remain. Okay, saya nak tengok berapa remain, so I should let U1 at the bottom. Because U1 represent 100%. Okay, U1 represent 100%. So it is equals to my Q2. Q2 is 0.6 Q1. And then square the whole thing over Q1 squared. Okay, over Q1 squared. And then if you got it right, U2 over U1 is then equals to, now, when you put 0.6 Q1 squared, what is going to happen is that you are going to square 0.6 and then you are going to square Q1. Okay, you are going to square both of them. So the value right here should be 0.36 Q1 squared over Q1 squared. Q1 squared and Q1 squared, you can cancel it out. So U2 over U1 is equals to 0.36. It means the remaining energy is 36%. Okay, 36%. So a percentage of energy. Okay, you have to write the full sentence ya. Sini kamu kena tulis ayat lengkap. So percentage of energy still stored in capacitor is 36%. Okay, is 36%. So that is how you solve questions 2. So learn how to use this method. This method is very, very useful. Okay, it's very, very useful. It can be used in every single chapter. So kalau Anda memang betul-betul tak boleh buat begini, apa yang Anda boleh buat? Okay, it's a slightly longer. Of course, you can still do it. I'm going to show you another method, but I would encourage you to learn the first method. So the second method, you can use U1 equals to 1 over 2C. Here is your Q1 square. Now, you can use these equations to calculate the values of capacitance first. And then you sub it into second equations, U2 equals to 1 over 2C Q2 squared. From here, you then calculate values of U2. Okay, from here, you then calculate the values of U2. Then after that, you calculate the percentage. All right, you got this one and then you got this one. So your final answer would be in terms of U1. How many U1? U2 equals to how many U1? Your C is equals to what? Values of U1. Okay, kamu punya C nilai dia in terms of U1, kamu punya U2 pun in terms of U1. Dari sini baru kamu kata what is the percentage. You got a 36% right here. So if you look at these two equations, the C is without subscript. Why? Because you're still looking at the same capacitor. If you're still looking at the same capacitor, then it means you have the same capacitance. That's why if you look at the solutions in the purple color, the C is without subscript, because they have the same value, okay? They have the same value. They are the same. All right, so that is one of the method that can be used to solve it, right? So personally, I would encourage you to use the one in orange color, because orange color is more practical, which can be used in every chapter, okay? In every chapter. So now I give you 2 minutes to write it down, especially the one in the orange color. Okay, especially the one in orange color. So when it comes to these questions, the score is given to first one. If you know U and Q, they are proportional. Okay, if you got U1 is proportional to Q1 square, then this is K1. K1 means you got the right concept. You know the concept. Okay, you know the concept. And then the second marks is given to the substitution. If you substitute Q2 equals to 0.6 Q1, then you score gantian satu marker. And then final answer. Now, final answer is not 0.6. You need to answer the question. Question is asking for percentage. So if you got right now 36%, then you got JU1. Okay, so this is a 3 marks question. First mark, second mark, third mark. right, now questions number 3. So figure 3, it shows an electric current circuit consisting of a battery of EMF 9 volt. Okay, so you are given EMF 9 volt and internal resistance 1 ohm. So this question, now it gives you this 1 ohm is actually your internal resistance. And then 2 resistor and 2 switch. Calculate the terminal potential difference of the battery if, now questions 1, if both S1 is open and S2 is open. If both switches open, then you don't have a complete loop right there. Without loop, what does it mean? It means no current flow. No current flow, what does it mean? It means no internal resistance. So in this case, the terminal potential difference of the battery, so this whole thing is the battery. What we want to see right now is the terminal potential. We want to look at the potential between this point and this point. This is what we call terminal voltage. Okay, terminal potential difference. So now when it comes to this case, since there's no current flow in the circuit, therefore V terminal straight away equals to EMF equals to 9 volt. Okay, so this question just one question, 1 mark. So if you got it right, you got 1 mark. All right. Now in exam by right, you should say VT equals to EMF. If you just give me 9 volt, then I don't know whether you are giving me the information from the questions or you are telling me that is the answer. Okay, so you need to show VT equals to EMF equals to 9 volt. Kalau tidak, saya tak tahu apakah 9 volt ini. All right. And then questions 2. Okay, questions 2. Questions 2, if S1 is closed and S2 is open. So when it comes to questions number 2, the circuit that you have right now, it looks like this. S1 is closed and then S2 is open. Means that S2, the 6 ohm resistor is not connected to the circuit. So you have 3 ohm right here, 1 ohm right here, and 9 volt right here. So question asks you to calculate the terminal potential difference of the battery. So you want to calculate the terminal potential. Let's say now this is your battery. Okay, because the battery includes an internal resistor. So this is the battery. So the voltage across the battery is equal to the voltage across, the potential across your external resistor. Okay, battery and this external resistor, they are connected in parallel. So they have the same terminal potential difference. Therefore, you can solve it by using potential divider equations, potential divider method, which is your V terminal. Okay, V terminal is equals to your R. Okay, I'm going to label the diagram first. I'm going to call this R2, this one R1, this is small letter R. So R1 over, now actually you are determining the V for 1. But this V for 1 at the same time is your V terminal. Okay, so V terminal is actually your V1 is equals to R1 over, now whole circuit you have R1 and small letter R. So R1 plus R times the EMF. Therefore, your V terminal is then equals to 3 over 3 plus 1 and then times 9. So V terminal is 6.75 volt. Now, there are quite a lot of you coincidentally get the right answer, but your concept is totally wrong. Okay, therefore you got 0 mark. So if you got the substitutions right, you get 1 mark. Final answer with correct, you need 1 mark. Now, some of you like to use the series circuit method to solve it. Of course you can. Okay, of course you can. How are you going to solve it by using the series circuit method? Now, let us go through it as well. Okay, let us learn the method as well. Okay, kita belajar satu lagi cara di mana Anda guna series circuit punya kaedah untuk jawab dia. So if you look at this diagram, this is a series circuit. You cannot treat it as a parallel circuit. Quite a lot of you calculate the R by using parallel circuit method, which is wrong. Because this is series. How are you going to calculate it by using parallel method? So the second method that you can use to solve it is to determine the values of current first, which is V equals to IR plus R. Okay, they are in series. Your external resistor and internal resistance, they are in series. So cara kamu kira R sudah salah sebab ramai guna parallel. So V is equals to IR. Okay, now in this case, I have the EMF, which is 9. Okay, this one should be more precise, should be EMF. So 9 equals to I, and then 1 plus 3. 3 plus 1, sorry. 3 plus 1. Okay, then you have I equals to 9 over 4. Okay, ampere. So once you have I, yes, then you can use the terminal voltage equations to solve it. Vt equals to EMF minus IR. Okay, then you sub the value into the equations. Eventually, you're going to get the same answer, which is 6.75 volt. So both methods, they are correct. Okay, both methods, they are correct. Just that one, you calculate the current first, and then the second, the other one, you straight away solve it by using potential divider method. All right, so this is method 1. And then this is method number 2. Okay, ramai nak guna method kedua, tetapi Anda salah kira R. These are, they are in series. Okay, they are in series. All right. Then how about questions number 3? Questions number 3, it tells you now both S1 and S2, they are close. So when it comes to questions number 3, the circuit that you have is like this. This is your 6 ohm resistor. This is your 3 ohm resistor. And then this is your internal resistance, 1 ohm, and your EMF 9 volt. So when it comes to this question, okay, how are we going to solve it? We need to simplify the circuit first. We need to simplify this part. Okay, simplify it by using parallel circuit method. So 1 over R 2 is equals to 1 over R1 plus 1 over R2. So 1 over R12 is equals to 1 over, my R1 is 3 plus 1 over 6. If you got it right, your R12 should be equals to 2 ohm. So if you got this method correct, then you get 1 mark. Okay, if you know how to simplify the circuit. So after you simplified it, the circuit now looks like this. Exactly same as your previous question. So this is your R12 and this is your internal resistance. Okay, so this is your 9 volt. So R is still 1 ohm. Your R12 is equals to 2 ohm. Instead of 3 just now it is equals to 2 ohm. So basically, you can repeat the step in question number 2 right now. Just like question 3, you have an additional step to simplify R1 and R2. After you simplified it, now the circuit is exactly like what you have in the second questions, in question number 2. So it's up to you whether you want to use method 1 or method 2. Okay, kamu nak guna kaedah 1 ke kaedah 2, terpulang pada Anda. But now you have the diagram that is exactly the same. Okay, what is the difference here is that now your R12 is 2 ohm. Just now the R is 3 ohm. That is the only difference. Okay, so if you are going to use the first method, then Vt is equals to V12, which is equals to R12 over R12 plus R, and then times EMF. So it is equals to 2 over 2 plus 1 times 9. So your V terminal is now equals to 6 volt. So questions 3, if you got the substitutions, the value correct, 1 mark. Final answer with correct unit, 1 mark. Okay, final answer with correct unit, 1 mark. So I give you a few minutes to write it down. This is a very good question because it tests whether you understand the series parallel concept or not. All right, if there's something that you don't understand, please ask. Very simple questions. This last question actually is a questions in your physics alert 2 or 3 weeks ago. Exactly the same. So questions B. 2 batteries in figure 4, they have a negligible internal resistance. So it asks you to calculate the current in the circuit. So now you have just one loop. When you have just one loop, what are you going to do? You are just going to start from one point, and then you follow the directions of current, okay, and then you travel through the loop, okay, you make a loop. So this is your traveling loop, okay, kamu buat satu loop, and then let's see how are we going to solve it. Okay, start from one point. So this is the loop that we're going to use, and now what is the equations that we're going to use? Now you don't have junction. Then it means you don't have to apply Kirchhoff's first law, because Kirchhoff's first law only exists if there is a junction. Then Kirchhoff's second law, the rules tell us that summations V is equal to 0. You need to write this down. This equation itself, it worth 1 mark, K1. Marker concept. Okay, marker concept. So now let us start to travel along the loop. Okay, so let us begin here. Okay, let us start from this point, the blue color point. So now if I start to travel from here, when I passes through the first resistor, directions of current and the directions of the loop, they are pointing toward the same direction. When they are pointing toward the same direction, it means now it experiences a potential drop. So you have negative 40I right here. Okay, potential drop. So this is a negative 40I. And then as it keeps traveling and passes through the second resistor, so the traveling direction is still going to the left, and then the current is still going to the left. Both of them, they are traveling towards the same direction. This is a resistor. So once again, our current, our charge, it experiences a potential drop again. So minus 30I. Okay, this 30I, 40I, they are actually your V. Okay, because V is equals to IR. So R is 40, I is unknown. So negative 40I means potential drop. Okay, this negative stands for potential drop. And then as it keeps traveling, okay, the charge keeps traveling, and then now it passes through your 15-volt battery. If you look at the battery, positive terminal is right here, negative terminal is at the bottom. So the directions of current flow is the directions of the traveling, the loop is against the directions of the current flow. Okay, you have a battery, positive, negative right here. So if it's traveling from positive to negative, then once again, it experiences a potential drop. Okay, a potential drop because it's traveling from higher potential, which is positive, and towards lower potential, the negative end. So another potential drop here you have negative 15, minus 15. All right. So now you keep traveling and once again passes through this 70 ohm. So 70 ohm, now directions of current is going to the right. Directions of the loop is also going to the right. So once again, it is a potential drop. Negative 70I. Let's keep traveling. And now it reaches the 60 ohm. 60 ohm, well, directions of the loop and the directions of current, once again, they are pointing toward the same direction. So it experienced another potential drop. So minus 60I. Okay, and then let us keep traveling. Okay, until it goes back to the original position. But before it reaches the final destination, it reached the starting point, it passes through this battery. And it's traveling from the negative terminal towards positive terminal. Negative terminal is lower potential, positive terminal is higher potential. Means now your charge experience a potential rise. So plus 20 and then equals to 0. Okay. So when it passes through the battery, then you look at it travel from positive terminal or negative terminal. If it's from positive towards negative, then it experiences potential drop. If from negative towards positive, then it experiences potential rise. Okay, experience potential rise. So now we have these equations already. Okay, so what are you going to do next? You just simplify it. So if you simplify it correctly, you are going to get I equals to 0.025 ampere. Okay, 0.025 ampere. So that is how you solve questions 1. So if you got the value correct, okay, if you got the values correct, then you got 1 mark for the Gantian. And then final answer with the correct unit, JU1. Okay, JU1. All right, you write it down first. I'm going to redraw the diagram for a while. Okay, so now let's look at questions number 2. Questions number 2, you want to calculate potential difference between x and y. Okay, you want to calculate between x and y. So now let us just pick one path to travel from x to y. Okay, it's up to you whether you want to pick the one from the left-hand side to from x through 30 ohm, 15 volt, and then 70 ohm to y, or you want to use the other loop. Okay, totally up to you. Tak ada masalah. Okay, it's up to you which path you want to take. So now let's say, now let's say I want to take the path from y until x. Okay, I want to take this path. Let's say I want to take the path on the right-hand side. So what am I going to do? So I'm going to start to travel from Vy. So my Vy, I'm going to write it down first. Vy, okay, if I travel from Vy, and then when it passes through the first resistor, now the current and the loop, they are pointing toward the same direction, and the path. Okay, the path and the current, they are pointing toward the same direction. It means it experiences a potential drops. So minus 60I. Okay, minus 60I. And then I'm going to keep traveling. Okay, I'm going to keep traveling. I change the color. So I travel through the 60 ohm. And then I'm going to keep traveling, and now it passes through the 20-volt battery. Okay, as it passes through a 20-volt battery, what is happening? So it experiences potential rise. So plus 20. Okay, plus 20 right here. And then as it keeps traveling, now it passes through another resistor. So potential drops again because now the directions of the traveling, the travel directions and the current, they are both pointing toward the same direction. So it experiences another potential drop. So minus 40I, and then it's going to be equals to Vx. Okay, it's going to be equals to Vx. So based on the path that I draw right here, my Vx is the final position, Vy is the initial position. So the difference between x and y, Vx minus Vy, it's equals to 20 minus 60I minus 40I. Basically, I'm just going to rearrange it. Okay, I'm just rearranging the equation because you want to find the difference. And it is up to you because this question is say between x and y. Between x and y, it's up to you where you want to take it as an initial point, which one is the final position. It totally depends on you. Right now, in this solution, I'm taking x as the final position and y as the initial position. That is what I'm doing right now. If you want to take y as a final position, x as the initial position, also can. Just that you're going to get a negative sign in your final answer. Tak ada masalah, okay? Totally tak ada masalah. Sebab dia cuma kata between. So between is up to you whether you want to use Vx minus Vy or Vy minus Vx. So if you use Vx minus Vy, then this one is going to be equals to 17.5 volt. Okay, if you got it right, you're going to get 17.5 volt. So this is just a very simple question. Therefore, it's just a 1-mark question. GJU1. All right, GJU1. If you know how to solve questions 1, then you should know how to solve questions 2. All right. So kalau kamu guna Vy minus Vx, then your answer is just negative 17.5. It is also correct. Tak ada masalah. Sebab apa? Sebab soalan kata between. Soalan tak sebut from x to y atau from y to x. Kalau soalan ada sebut, if the questions got mentioned from x to y or from y to x, then you must follow the position. Okay? If we say from x to y, then you have to use Vy minus Vx. If you say from y to x, then you have to use Vx minus Vy. But if you say between, then it is totally up to you. Now you see the difference? All right, cool. So that is the last question.